We're going to continue with lesson 3.1 at the bottom of page 117 with a fun topic of learning what imaginary numbers are. Imaginary numbers were once thought to be impossible, and that's why they called them imaginary, to make fun of them. But then people realized that they are actually useful and important because they fill a gap in mathematics, and the name stuck. Think about back when mathematicians introduced negative numbers. Negative quantities, it was very new to people. And that's how imaginary numbers are going to feel to you at first. An imaginary number, it's just basically the square roots of negative numbers. We have one called I. We call that the imaginary unit, and it represents the square root of negative 1. So here's our I equals the square root of negative 1. So you can replace the square root of negative 1 with the letter I, or you could replace I with the square root of negative 1. Here's some other examples of imaginary numbers. We can write 2i, negative 5i. We can even put it as part of a fraction or a ratio. We can write it with a square root. In this case, we want to put the I before the radical symbol. We don't want to mistakenly put the I underneath the radical. So if you put it first, I square root of 2. And we can also include a radical with a ratio, I square root of 3 all over 2. Next, we're going to look at squaring an imaginary number. So let's start with I is equal to square root of negative 1. If we take I to the second power, that's the same thing as squaring the square root of negative 1, which we get negative 1 as our answer. Let's look at I to the third. We can rewrite that as I to the second times I to the first. Now I to the second we just said was equal to negative 1 times I is simply negative I. I to the fourth, let's rewrite that as I to the second times I to the second. That is simply negative 1 times negative 1, which gives us a positive 1. When you get down to I to the fifth, you're actually looping around, and it will give you the same answer as I. So let's look at how we can use this looping that goes around in a cycle to find something like I to the 18th power. Take the exponent, divide it by 4. That gives us 4 remainder 2. And we're really interested in that remainder 2 because that means I to the 18th is the same as I to the second, and we know I to the second is negative 1. Okay, looking at the next page, example 3. All right, the book has already done example A, 5a, and we want to square that term. So we're going to raise the entire quantity to the second power. Remember our product rule. That means we have 5 to the second times I to the second. 5 to the second is 25. I squared is negative 1. Multiply and you get negative 25. So let's try that with the example B. All right, so we want to take negative I square root of 2 and we want to square it. Well, let's first square the I. So the I is going to come out here at the end. What's left is that negative out front and the square root of 2. And the entire quantity needs to be squared. Well, what happens when you square a negative number? It turns positive. And the square root of 2 raised to the second power, okay, keep in mind that that radical symbol right there and the exponent of 2, they cancel each other out, and we're left with the number 2. 2 times I squared, which we've already talked about is negative 1, we get negative 2. Let's go down to 9 and let's do some of these together. All right, we want to square negative 2i. Let's rewrite that as the quantity negative 2 to the second power and I to the second power. All right, negative 2 squared. That's negative 2 times negative 2 gives us a positive 4. I squared, we've talked about, is negative 1. Multiply those together, we get negative 4. All right, let's try another one, number 10. All right, let's start by squaring the entire quantity. If I separate it, we get negative 3 over 3 quantity squared times I squared. All right, the square root of 3 over 3, that means both of those, the numerator and the denominator, are going to get that exponent. So we get the square root of negative 3 squared is simply 3. 3 squared is 9. I to the second power, by now hopefully you have that memorized, is negative 1. Multiply and simplify the fraction and we get a negative 1/3. Now that you know how to work with an imaginary number, let's look how we use imaginary numbers when we're solving quadratic equations, and we're actually going to get imaginary solutions, not just real solutions. We're going to start with example B on the next page, on page 119. All right, here we have the equation 4x squared plus 11 equals 6. All right, of course we're going to start by subtracting 11 from both sides, which gives us negative 5 on the right side. Divide both sides by 4 and we get negative 5 over 4. And then at this point we can take the square root of both sides and we get x equals plus or minus negative 5 over 4. I'm going to rewrite that over here on the side so you can see how I can rewrite it as the square root of negative 1. All right, let's try that up here where I have a little bit more room. I can write that as the square root of negative 1 times the square root of 5 over 4. In that case, I can take that square root of negative 1 and replace it with an I. So here is our I right here. And then I just have to simplify what's underneath the radical. So I have now the square root of 5 over 4. We know that we can write that as plus or minus I. Square root of 5 does not simplify, but the square root of 4 does, and that is 2. Let's try another one together. Under your turn 11. All right, let's begin by subtracting 9 on both sides. All right. Then we're going to multiply both sides by 4. Or you can think of that as 4 over 1 if you'd like. And on the left side we're left with x squared equals a negative 36. All right, let's take the square root of both sides. And we end up with x equals, don't forget your plus or minus sign, the square root of negative 36. So I'm going to write that as the square root of 36 times negative 1. That way I can see, hey, there is my I right here. And I can pull that out of the radical. Actually, I'm just replacing the square root of negative 1 with the letter I. So I can write that as x equals plus or minus I, and I still have the square root of 36. Well, we know the square root of 36 is 6. So our final answer, x equals plus or minus 6I. In this case, we always put the imaginary number last. Now it's your turn to do number 12 on your own. And I hope you have enjoyed your first lesson on imaginary numbers.